Hey, everybody. Um, this is your packet that I passed out to you on Friday. It cut off the top of mine for some reason, but yours should say Monday virtual class or Monday 125 at the top. Okay. All right. So this is your bell work, I'm pretty sure. Yes. Okay. So make sure you do this. So I'll help you on a couple of them. So this is where we're using like angle, side, angle. We're using sassy triangles, my favorite. Side, side, side. Angle, angle, side. Hypotenuse, leg. Did I miss one? No. Okay. So let me make this green. Okay. So you're going to name the triangle in the same order that it's named here. So I'll show you what that means. All right, so triangle ABD is congruent to triangle. Okay, we have to name it in the same order. So you see how it started out here, went to B and down to D? We're going to have to do the same thing. So we'll have to say triangle CBD. Okay. All right. So we need to, right now we only have two parts that show that the triangles are two congruent parts. And remember, we need three congruent parts to prove that two triangles are congruent. Okay. So we have a pair of sides and we have a pair of congruent angles. We're going to erase some of this. Okay. So we have a pair of sides. Make that a little thicker. So these are my two congruent sides. And then I have two congruent angles. So I need something else. All right. Well, these two triangles share this side. So it's congruent to itself. Okay. So right now I have side, angle, side. So triangle ABD is congruent to triangle CBD by side A side. Thank you, Siri, or whatever. All right. So let's look at, so you're going to do number 2. Then let's look at number 3. So right here, I have two pairs of congruent angles and one pair of congruent sides. So when I look at these, it has to match. So this one has a pair of congruent angles, and this one has a pair of two congruent angles. So I have to choose one of those. Now, so is it angle, side, angle, or angle, angle, side? All right, well, my pair of sides is in between my two angles. So that would mean I would use angle, side, angle. Okay, so let's try to name them in the same order. Okay, so let's try to name them in the same order. So if you look, EMN, so EMN. So if we look at the other one, so if you look, E is the angle with two arcs. So I'm in this triangle going to start with the angle with two arcs, which is P. Okay, then it goes to the unmarked angle M. So I'm going to go to the unmarked angle Q. And then it goes to the angle with one arc N. So I'm going to go to the one arc R. So that's how you would name that. So you have to name them in the same order. I know that's crazy, but you'll get the hang of it. All right, so let's try another one. I gave you part of number 5, so I'll go ahead and finish it. So triangle YZA. So YZA. So I have to name the other triangle. Since they're congruent, you don't do this if they're not congruent. Okay, I'm going to name the other one in the same order. So I'm going to start at the top because that's where the other one started. then I go past the congruent side. So I go past the congruent side. So that's Y down to B and then to A. Okay. So you're going to do this, but I'm going to, oops, sorry, not that. You're going to do the reason here, but I'm going to help you name it because it kind of gets kind of crazy. All right. So STU. So it starts at S. So that's the angle that's between my side with 2 arcs and my side with 3 arcs. Or not arcs, I'm sorry, lines. So I got to look between the side with 3 arcs, 3 marks and 2 marks, which would be angle V. So I'm going to start with angle V. If you have a highlighter, this is when it would be really good to highlight the different sides. So if I look TU, why is it not doing that? It literally just did it a minute ago. All right, never mind. So TU, that's the side with 1. So I'm going to go here. Okay. All right, is congruent to WX. So let's change colors. ST is with 2 lines. So I'm going to go over here. This has 2 lines, same color. So that means they're congruent. All right, and then let's do yellow. So this has 3 lines, so it's congruent to WV. So this helps you kind of name the triangles, and that's why I said it's important to have, let's do green because we haven't done that. It's important to have different colors. So S is the letter that it starts between pink and yellow. So I'll look here. V is between pink and yellow. All right, and then it goes to T. T is between blue and pink, so X is between blue and pink. And then the last letter, W. Okay, so you'll need to try 2 and the reason for this one, and then try 6. Okay, so objective today is that, you can prove 2 triangles are congruent. I can make it fancier than that, but I won't be able to fit that there. Okay, so let's scroll down. All right, so this is a part of your bell work / homework. So what I want you to do is, so classify this triangle by its side lengths. How do we find that? All right, so that means you need to use the distance formula on each side. So if I want the side of EF, I need to do the distance formula. All right, so that I need to use the 2 points. So F is 1, 0. E is 5, 5. Okay, so let's look. So I'm going to do the square root of, remember it's x minus x, so 5 minus 1 squared. The next one is y minus y, so 5 minus 0 squared. So I've got 4 squared, which is 16, and that's 25. All right, so I've got the square root of 16 plus 25. So you can find that. Let me see if I have the, I didn't bring my calculator home. So the square root of 41. Oh, here we go. All right, so you get about, 41, sorry. You get about 6.4. All right, so you'll do the same, the distance formula for DF, and this one you can just count, really. So from -3 for D to +5, that is 8. Okay, so you just need to find this side. So it's not going to be equilateral, right? Because equilateral triangles have all congruent sides. So see what you can find for this. And if it's the same as 6.4, then it's isosceles. All right, so finish that one. You're going to do the same thing here. So you're going to use the distance formula. If you want to use the Pythagorean theorem, that's fine with me too. So this is the distance formula, and if it has all 3 different sides, then it's scaling. All right, so let's look at this. Algebraic proofs. So what you're going to do is basically you're going to solve, but you don't write your steps in between, okay? So your first thing is always given. So what would be my next step? Well, if I were to solve, I would add that 6, right, to both sides. So you're going to write your result after adding 6 to both sides. Okay? Now, how did you get from step 1 to step 2? You had the addition property. I'm going to try to zoom in. All right. Zoomed in a little too much. All right. So now what would you do after that? Okay, you would divide by 4. So you're going to write the result after you divided both sides by 4. Now, how did you get there? From step 2 to step 3, you did division property. All right, so if we look, you were given this algebraic statement and you need to prove that x equals 4. Did you get that? Yes, you did. Okay, so that is a proof. So after we do the algebraic proofs, we will work on doing this with shapes. So basically, we'll be using what we did for bow work. We'll be using this information to help us prove. Okay. Oh, a little too far. All right. So if you look, do not show your work in the columns, only show your outcomes. So let's look at, I'll do this one. So you'll do number 2. All right, so you always write your given first. So I wrote it in there for you, but when we do proofs, you always write your given in there first. Okay, then this should always be your last statement. Okay, so I'm going to distribute this -2 to each thing. So my next step, you cannot combine steps or skip steps. So that'll be -18 plus 16x. Okay, so what was that called? How did you get from step 1 to step 2? That was the distributive property. Okay. Now, I need to combine this x and this 16x. So that is 15x minus 18 equals 12. All right. So now, how did we get from there to there? That we can call that combined like terms. Okay. So then you would solve from there. All right, so then we have our 18. So we add our 18 both sides. Remember, don't show your work. You just show the result. So if I add 18 to both sides, I get 30. So how did I do that? How did I get from step 3 to step 4? Well, I added, right? So I use the addition property. Okay, then last step, to solve for x, I would divide by 15 on both sides, and my result would be 2. Okay, so that is called the division property. All right, so let's look. So you're going to have to do this one. All right. Okay, so very important for proofs, so we'll need this. All right, so reflexive property of equality. So that just says, this is like for algebra. Okay, so this just basically says, like, x equals x. Boom. 2 equals 2. Ooh. Undo that. 2 equals 2. X plus 2 equals x plus 2. Okay, so the same thing happens in geometry, but we've kind of already touched on it. We've talked about, like, if triangles share a side, then we use the reflexive property of congruence. So that would be like side CA is congruent to itself, side CA. So that was like when we had a triangle and they had C and A. All right, so that's when they share that side, so it's congruent to itself. You can also have, let's say I have a big triangle and I have a smaller one within it. Oh no, that's similarity. Let's not do that. So triangles can also share an angle. Let's see. If they share an angle, that's normally used in similarity instead of congruence. All right. So that doesn't come up that often for angles, but it will for sides. All right, so that's when they share a side. Okay, you can have angle A is congruent to itself, angle A. All right, so this weird thing, CPCTC, what the heck is that? So that's corresponding parts of congruent triangles are congruent. You're like, didn't you just say congruent twice? That's weird. All right, corresponding. Remember, we were talking about how that's the same angle or the same line segment in two different triangles. So let's say I had these two triangles. All right, let's say they're congruent because Ms. Higdon is a great drawer, right? All right, if I already know that these two are congruent, exact copies of themselves, okay, then I can say their corresponding parts are congruent. So if I have triangle ABC is congruent to triangle DEF. Okay, we only know this when we already prove that the two triangles are congruent, or we already know. We can't use this until we know that both triangles are congruent. Okay, so this is only used after we've found out that both triangles are congruent. Okay, so if I know that these two triangles are congruent, what's their corresponding parts? All right, so corresponding parts, A is in the bottom left. Well, what angle is in the bottom left? D. So those two would be congruent because they are corresponding. All right. So let's look at angle B would be congruent to angle E because I know these two triangles are congruent and they are in the same spot in each triangle. So angle C would be congruent to angle F because they are in the same spot in both triangles. So same can be said for the sides. So if you have congruent triangles, their corresponding parts are congruent. Okay, so AB would correspond to DE. So therefore they are congruent because I know that these two triangles are congruent. Once again, you cannot use CPCTC until you know that these triangles are congruent. All right, so BC would correspond with EF. They're congruent. And AC would correspond with DF, so they're congruent. All right. So this is the setup of a proof. Your givens are always first. You may have one given, you may have like 5 givens, okay? So your givens are always written first. Okay? Then this is where you have all of your statements. Okay, this will be like a lot of vocab and theorems and properties. Okay, on the left is always going to be your geometric statement. So you're going to have like GF is congruent to RT, something like that. Okay, this is where all your geometry statements come from. Okay, you could have like, something like angle A is bisected by angle by ray RD or something. Okay, then the last statement is always what you needed to prove. Okay. Okay. Okay, so we talked about this one yesterday. On Friday. This one doesn't come up as often, but remember hypotenuse leg. Okay, that means that the hypotenuses are congruent and they have one corresponding leg that's congruent. And it can only be with right triangles. Okay, so we're going to name this in the same direction. So you don't have to do an alphabetical order, but we're just going to. So I'm going to do A, B, C. So triangle A, B, C. I'm going to do that again. So A, B, C. So I'm going to start over here. That would be congruent to triangle D, F, E. You have to name them in the same order. Okay, by HL. So this will normally be your last statement in your proof. Okay, this part will be on the left side and then HL would be on the right side. Okay, but sometimes we'll be proving different things. All right. So let's try to do this with geometry. Yay. Okay, so I have AC is congruent to BC. So what you always do first is label. Always label what you're given first. I promise it'll help. If you don't label it, you're going to be very lost. All right, so AC is congruent to CB. So I'm going to mark those congruent. Remember, you need 3 congruent parts to prove that 2 triangles are congruent. Okay? So CD bisects AB. Now, remember we talked about when we bisect something, we get two congruent parts, right? So when I bisect, that means that I get two congruent segments. All right, what else do we know? We don't know anything about angles. It didn't say it bisected the angle, but we do know that these two triangles share this side. So I know it's congruent to itself. So right now, I can use this. Okay, I know triangle ADC is congruent to triangle BDC. All right, I wrote that backwards. Okay, how do I know? By this gives me, this is where those side, angle, side, angle, side, angle, side, and HL come into play. How are they congruent? By side. All right. So what we just did, what we just talked about, we're going to fit all that into a cool looking proof. Okay. So your given is always first. So let's write that first. So AC is congruent to CB. Okay. What's the reason? It's given. Okay. My next given, CD is not congruent. CD bisects AB. Now, how do we know? Given. So now we have to get, so far, remember we need three congruent parts, right? Right now we only have one, so we cannot prove this in our proof. So let's look and see what we did over here. All right, from this statement, what did we learn? From CD bisecting AB, we learned that it broke it into two congruent parts. What are those two congruent parts? Well, AD is congruent to DB. So I'm going to write that here. Now, what's the reason? How did we know? Well, we knew that because we know what bisect means, right? So if it's in here, you're most likely going to use that word in your reason. So definition of bisector. Now, you could see like definition of segment bisector. That's fine too. I'm fine with definition of bisector. All right. So now we've got 1, 2 congruent parts. How many do we need? 3. All right. What was our last thing we found? So think this is where we had CD is congruent to itself. CD. Now, what was that called? That was called the reflexive property. All right. So now I've got 3 congruent parts. Okay. And are those legal? Yes. So I have triangle. Remember, what you need to prove is always your last statement. ADC is congruent to triangle BDC. And how do we know? By side. All right, what time are we at? You're probably like, oh my God, we're never going to end. Okay. So let's look at another one. You're probably like, oh my God. You will have, don't worry, you will have your own list. Well, I thought so. All right. So let's look at this one. So remember, first label. So prove this, okay, given angle A is congruent to angle B. And DC bisects this angle. All right? When we bisect something, we get two congruent parts. So if I bisect an angle, that means I get two congruent angles. Does not tell me anything about this side. It only talks about this angle. So I get two congruent angles here. All right, so do I have three parts? No, I do not. So what's my last part? Side CD is congruent to itself. So are these two triangles congruent? Yes. By what? By angle, angle, side. Now, why isn't it angle, side, angle? Well, for that to happen, you would have had to have the side in between the two angles congruent. But we do not know anything about that. We were not told. Okay, so I only know that this side, the side CD, is congruent to itself because they share that side. All right, so let's put basically what we just talked about in a proof. So remember, write your givens first. So angle A is congruent to angle B. What's our reason? It was given. Okay, next one, DC bisects angle ACB. Why? How do we know? Given. All right, so now, did we learn anything from that? No, we just learned they're congruent, okay? Did anything happen from this statement? Yes. From bisecting that angle, we got two congruent angles, so we need to name them. I cannot say angle C because angle C refers to two angles right now. So we need to name those. All right, so that's angle ACD is congruent to angle BCD. Now, what's the reason? How do we know that? Well, we know what bisect means, right? So we need to put that here. So definition of angle bisector. All right. So if we look at our proof, remember we need three congruent parts to prove that two triangles are congruent. So right now I've got 1, 2. So that's not 3. So I got to find that third one. All right. Well, I know that CD is congruent to itself. So CD is congruent to CD. How do I know? Reflexive property. So now do I have 3 congruent parts? Yes. So can I say that those two triangles are congruent? Yes. So now remember, what you need to prove is always your last statement. So a triangle ACD is congruent to triangle BCD. How? By AAS. Ooh. Okay. Almost done. All right. So let's look at this. Remember, label, 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 label. So AE is perpendicular to ED. So that's a right angle. BC is perpendicular to CD. Right angle. D is the midpoint of EC. All right. If that's the midpoint, then that means that ED is congruent to DC. Okay. And then angle 3 is congruent to angle 4. All right, so right now I've got 3 congruent parts, 2 angles, and 2 sides. All right, so right now it's angle, side, angle. All right, so this one's a little trickier. Okay, so let's put our givens in there first. So AE is perpendicular to ED. How do we know? Given. BC is perpendicular to CD. How do I know? Given. D is the midpoint. of EC. How do I know? Given. And angle 3 is congruent to angle 4. How do I know? Given. All right. So now I only have one congruent statement. And remember, I have to have 3 congruent statements to prove that 2 triangles are congruent. All right. So we're like, wait, those angles are congruent. Yes, but right now we have that they're 90. Okay. So I have angle E and angle C are, you can put 90 degrees or right angles, but we're going to put right angles. How do we know that these 2 angles are right angles? What told us here? All right, so what told us was that perpendicular sign, right? So that would be definition of perpendicular. Okay, so now that they're right angles, we can say that they're congruent. So angle E is congruent to angle C. Why? All right angles are congruent. Okay, so now I've got 1, 2 congruent parts. I need a third one. All right, so that was this side, right? So I know that ED is congruent to DC. How do we know that ED was congruent to DC? Okay, what told us in our proof here? Okay, we found that out from D is the midpoint, right? So instead of definition of bisector, we have to use definition of midpoint because we have to use the language that's given to us, right? So definition of midpoint. Okay, so now I have 1, 2, 3 congruent parts. All right, and you have to make sure they're in the right thing. So I'm gonna have to extend my proof. All right, so now can I say these 2 triangles are congruent? Yes, so triangle AED is congruent to triangle BCD. That's supposed to be all on one line, but I didn't give myself enough room. Okay, how do I know? ASA. Okay, that was a long one. That one's really intense. In college, my proofs they weren't 2-column proofs, they were sentences, like paragraph proofs. And a lot of my paragraph proofs were like 2 pages, 3 pages. All right, this is the last one. Yay! All right, so RS bisects PQ at T. All right, so remember, when we bisect something, we get 2 congruent parts. What are we bisecting? We're bisecting PQ. So PQ gets cut in half. What does that mean? That means I get 2 congruent parts. Okay? PQ bisects RS. So that means these 2 are congruent. All right? Prove those triangles are congruent. So in our labeling thing here, we only have 2 congruent parts. We have a third. Right? We have that these 2 angles are congruent. Why are those 2 angles congruent? That'll come up later. We need to know. Okay, those are vertical angles. All right, so I have 3 congruent parts in my thing. Yes. So I can prove these 2 triangles are congruent. All right, so let's write down our givens. RS bisects PQ. I'm going to write just that part because I can't fit that much more. Okay, Y given. PQ bisects RS given. Okay. Now I've got, so what did I learn from these 2 statements? Well, I learned that PT is congruent to TQ. Okay. How do I know that? Well, I know what bisect means, right? So definition of bisector. Okay. Then I learned from this statement that RT is congruent to TS. How do I know? That definition of bisector. All right. Now, remember, you have to have 3 congruent parts in here. What was our third congruent part in our labels? Okay, we had angle. You can't just say angle T because there's 4 angle T's right here. Let's get rid of some of this clutter. All right, so we have to name it RTQ is congruent to PTS. You can switch those letters around as long as T is in the middle. Okay, how do I know? That was the definition of vertical angles. So vertical angles are congruent. All right, do I have 3 congruent parts in here? Yes. Now, how are these 2 congruent? They're sassy. So triangle PTS is congruent to triangle QTR by what? SAS. Okay, fun times. All right, so I will have all the things that you need in your Canvas page. All right, so have a great day.